So in this video, we're going to look at the different forms of linear equations. And I want to start off by reviewing you about slope, which we examined in the last video. Remember, we talked about the slope of a line, and we're looking at linear equations. So it's actually the slope of a line. And if I could write the right letters, there we go. So we're going to look at the slope of a line real quick again, and then we're going to jump into the different formats of equations for lines. So if you remember, we had the slope of a line as m equals, and we called it the change in y over the change in x. Remember, the change in y is the vertical change of the line from point to point. The change in x is the horizontal shift of the line from point to point. And the way we arrived at finding that change was we took the difference in the two y coordinates divided by the difference in the two x coordinates. So basically the vertical change divided by the horizontal change between 2 points. And this is if we're given 2 points on that line. And you can take any 2 points on that line to find that slope. So we talked about that in the first video. Then we had the 4 types of slopes. Remember, you've got the positive slope, which is the slope that climbs from left to right. You have the negative slope, which is the line that falls from left to right. You have the horizontal slope, which is the line that has a 0 slope. There is no, and I'll put a little line through it, that's a 0. There is no slope. Sorry, there is a 0 slope for this line. Got a little distracted there, and I'm just going to make it just a regular 0. I don't want it to look like the empty set for any of you guys that are doing set theory. And we have the vertical line, which has no slope. And sometimes my platform doesn't work. So this one has no slope, or we also call this undefined. It is technically an infinite slope as well. So those are your 4 kinds of slopes. So we've identified those. Now what we're going to look at is we're going to look at the 4 ways that you can represent, or not the 4 ways, the several ways that you can represent the equation of a line. There's actually technically 5 types of linear equations that you're going to see. And so we're going to highlight those now. The first one, and I'm going to scroll up here. Let me get this moving. The first one is the most standard type of representation that you're going to see, and that is slope-intercept form. And this is called slope-intercept form because it shows you are able to look at the equation and tell the slope of the line and the y-intercept of the line. So slope-intercept form is y equals mx plus b. Now you should have seen this multiple times in Algebra 1, Algebra 2, and even in geometry. So m actually represents the slope of the line. And notice it's just m, not mx. Just m represents the slope of the line, and b represents the y-intercept. Now, technically, I shouldn't be circling the addition sign, but we usually take that sign, whatever it is, to recognize our y-intercept. Technically, if it's a negative y-intercept, it would be plus -5, plus -7, but we don't write it that way. We will write -7, -5 to make it easier for you. So when I gave you an equation in slope-intercept form, you should immediately be able to tell me what the slope of the line is and what the y-intercept is. So let's do some examples of slope-intercept form. I'm going to give you some lines here. Just some examples. And one more. Well, why not? Let's do a 5th one just because we don't want to do a 5th one, but we will. Okay, so there's 5 lines that are in slope-intercept form. So right off the bat, I should be able to identify the slopes of each one of these lines. First line, the slope, which we indicate with an m, is +3. And we will actually write that as 3 over 1 when we graph it so that we know we're going to go up 3 over 1. A positive slope is basically a positive over a positive. The slope of the second line, and again, I'm not circling the x. The x is not part of the slope, not for the equation. We're just looking at the coefficient, which is the number in front of the x variable. as our slope. So the slope of this one is -2. So that can be written as -2 over +1, or it can be written as +2 over -1. Either way, when you graph it using either one of these, you will get the same result. The slope of this line is -2/3. So once again, that's the same as -2 over +3, or it's the same as +2 over -3. What about this one? This always confuses people, but remember, what do we assume is in front of a variable if nothing is there? A 1, right? So the slope of this line is actually just -1, which is -1 over +1, or +1 over -1, however you want to look at it. And the slope of this guy is +7. So that's +7, and we can write that +7 over +1. Now, I'm not going to write everything out like this if it's a whole number, but I want you to see how we determine how to graph it from slope-intercept form. So when I put this line on the graph, my slope is going to be up 3 over 1, up 3 over 1. For this one, the slope is going to be down 2 over to the right 1, which is the same thing as going up 2 and to the left 1. This slope is going to be down 2 and over to the right 3, or you could go up 2 and to the left 3. It's going to give you the same shape. -1, that's the same as -1 over +1, so you're going to go down 1 to the right 1, which is the same as going up 1 and to the left 1. And this one is going to be a straight shot, up 7 over 1 to the right. So that's how you determine the slope. So now let's look at the y-intercepts. The y-intercept, remember, is where the line crosses the y-axis. If you ever watch football, they call it an interception because that's where the defender steps into the path of the ball. When we have a y-intercept, so if I were to draw a graph here, and I draw a line, that's my y-intercept because that is where the y-axis intercepts the line. So let's look at these y-intercepts here on these equations. This line is going to cross the y-axis at +2. This line is going to cross the y-axis at +5. This line is going to cross the y-axis at -6. This line is going to cross the y-axis at +4. And this line is going to cross the y-axis at -2. So just by having the line in slope-intercept form, we're actually able to graph the line. So let's actually look at how some of these graphs look and how we can put them on the grid just using the equation. Again, beautiful artwork here. Don't hate on me. And 1, 2, 3, 4, -5. And 1, 2, 3, 4, 5. So let's graph some of these guys. Well, the first one we're going to look at, let's look at line number 1. Where is the y-intercept of line number 1? +2. So I'm going to come over to the y-axis, and I'm going to go up to +2. Now I'm going to apply the slope. And what's my slope for the first line? +3 over +1, right? So I'm going to go up 3 and to the right 1. Now this is also the same as -3 over -1 because a negative over a negative is a positive, right? So to go the other direction, I just flip the signs around. 1, 2, 3 over 1. Because if I were to start here, if I would go up 3 and over 1, I'm in the same spot. So there's my first line. That's line number 1. Let's look at my next line. Let's look at line number 2. Where does this guy cross the y-axis? At 5. So it's going to cross the y-axis at 5. And my slope is -2 over +1. So I'm going to go down 2, 1, 2, but to the right 1. Down 2, to the right 1. Down 2 to the right 1. And remember, we talked about how you can determine, and sorry I can't draw the straight lines, we talked about how you can determine if a line is negative or positive just by the way it slopes on the graph. So if I were to look at this line immediately, I would be able to tell that it's negative. Let's graph the third one. So let's go purple. We'll graph line number 3. So my y-intercept is -6. I'm going to have to come down here a little bit. 1, 2, 3, 4, 5, 6 is where I'm going to cross. And my slope is -2 over +3. So I'm going to go down 2 and 1, 2, 3 over. Now remember, I told you that's the same as going up 2 and to the left 3. So my line looks like this. And again, do you see how line number 2 and line number 3, these two guys both have negative slopes? So they're both slanting to the negative side. So let's look at the next line. Let's do line number 4, and we'll make this one red. The y-intercept of line number 4 is at +4. So 1, 2, 3, 4. This is where I'm crossing the y-axis. My slope is -1. So I'm going to go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. So that line looks like so. Once again, this is a negative sloped line, so you see that it is leaning and slanting to the right, going left to right, down, and it's falling. So far, the blue line with the slope of +3 is our only positive sloped line. So let's look at one more. Let's do green, and we'll do this line with green. The y-intercept is -2, so I'm going to find -2 on the y-axis, and my slope is +7. So I'm going to go up 7, 2, 3, 4, 5, 6, 7, and over 1. I would then count up 7 and over 1, but my graph's not that big. So you can also see the green line, just like the blue line, has a positive slope. So that is slope-intercept form and how you graph from slope-intercept form. Now, there are vertical and there are horizontal lines, and we're going to talk about those. So let's look at slope-intercept form on another grid. So I'm going to draw a grid here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So let's look at this equation. Let's do slope-intercept form, but let's do y equals 5. Y equals -3. A lot of people will look at these two equations and go, that's not in slope-intercept. It actually is. But it's a special case when our slope is what? 0. That's 0x plus 5. This is 0x minus 3. There's no point in us writing the x term when it's 0, right? So what this is saying is no matter what you plug in for x, y is always going to be this value. So I'm going to put a point at y equals 5. That's my y-intercept, right? Would this not be my y-intercept? Same thing for this equation. This is my y-intercept. So for the first equation, y equals 5, I'm going to put a dot at 5. That's my y-intercept, and my slope is 0. So no matter what I plug in for x, my y value is always going to be 5. So it's literally going to be all these points along this horizontal line here, because every single point on this line has a y coordinate of 5. Let's check it out. This one is at 0, 5. This point right here is at 2, 5. This point right here is at 3, 5. This point over here is at -2, 5. Look at the y coordinates for all these guys. They're all the same. So that's basically what a horizontal line is. It has a slope of 0. Because the y value, the vertical, remember slope is change in y over change in x. This is slope. Vertical change over horizontal change. This line is definitely changing horizontally, but it's not changing vertically. Okay? So if I look at my second line, we're in the same boat. My y-intercept is -3. and my slope is 0. So no matter what I plug in for x, every point is going to have a y-coordinate of -3. So here's my horizontal line. That's why horizontal lines have a slope of 0. Look at this one, it's at 3, -3. This point right here is at 2, -3. Let's put another one over here. This point is at -4, -3. You can see that all of these lines have, all these points have a coordinate of -3. So it doesn't matter what x is going to equal, y will always equal -3. So you can see now why those equations don't have x terms. The x term exists, but the slope is 0. So no matter what we plug in for x, y is always going to be the same. So that's your horizontal line. And remember, horizontal lines always have slopes of 0. So the last thing I want to look at is the vertical line. And the vertical line is the one that's a little trickier. So I'm going to add one page. We're going to add a page. So I can do this. There we go. Gotcha. And I'm going to zoom in. So now let's look at the horizontal lines. Now the horizontal lines, the vertical lines. The vertical lines are those guys that we call undefined or no slope. And again, I know I've got beautiful artwork and wonderful straight lines. I'm using my Drawboard PDF program. So let's look at a couple of equations that look a little different. X equals 6. X equals -1. Okay, we just looked at y equals. Now what do we do with these? Okay, these are actually considered to just be vertical equations. Vertical equations, okay? So a vertical line is when it says x equals. Now what does that mean? That means no matter what I plug in for y, x is always going to be the same. So the question is, what is the y-intercept? Well, when we have y equals mx plus b, that's your whoops, sorry, didn't mean to do that. That's your y-intercept, right? But do I even have a y term in these two equations? I don't. So this is not really a slope-intercept form type of equation, if you want to look at it technically. This says x is always 6 no matter what. Doesn't matter what I plug in for y, x is always 6. So it is actually not possible for this to have a y-intercept. Let's check out this first one. If x is always 6, let me move this over a little bit. If x is always 6, what that means is every point is going to be 6. 6, 1, 6, 2, 6, 3, 6, 4, 6, -3, 6, -4. This is just going to be a nice vertical line where x is always 6. See this point? This is going to be 6, -4. This point is going to be 6, -3. This point is going to be 6, 2. This point is going to be 6, 3. You get the idea. Everything is 6. So there is no y-intercept for this equation. There will be no y-intercept for this one either, because no matter what is x always going to be? -1. I can put points all over the place as long as the x value is -1. And that is another vertical line. And again, pretend for just a second that I can draw straight lines. So this is at -1, -5. This is at -1, -4, and so on and so on. -1, -1, -1, 2, -1, 4. It doesn't matter. Every point on this line is going to have an x coordinate of -1. So we write x equals -1. These are considered to have no slope or an undefined and sometimes infinite slope. So this is undefined. Now, the only time you're going to have a y-intercept, possibly, is this. What happens x equals 0? Well, if x is always equal to 0, then my line is literally my y-axis, and then we have an infinite number of y-intercepts. Big concept, right? So anyway, this kind of explains to you how you do slope-intercept form and the four possibilities that you'll see here with those lines. Now, there are two more equations. There are two other types of forms that we can do besides slope-intercept. But with the length of this video, I'm going to go ahead and put these on the next video. So this is slope-intercept form, vertical lines, and horizontal lines.